It is arguably the most revolutionary assault rifle concept ever conceived. A weapon designed to solve a problem that has plagued firearms engineers for over 150 years, the brass casing. This is the story of the Heckler & Koch G11, a product of West German Cold War ambition. This futuristic weapon, designed in the 1980s, could fire 900 rounds a minute, store 50 rounds in a single magazine, and yet produce no shell, no visible flash, and almost no recoil. It achieved near perfection in meeting its revolutionary military specification. And yet, this scientific marvel, this weapon poised to equip the entire NATO alliance, never fired a single round in conflict. The program was cancelled, the technology shelved, and the rifles relegated to museum display cases. The paradox of the G11 is that it was killed not by enemy fire, but by its own staggering mechanical complexity and a catastrophic stroke of geopolitical timing. The problem wasn't the gun, the problem was the world. How did a rifle designed to be the defining weapon of the 21st century fall victim to a single political event? The fall of the Berlin Wall. And what secrets did its radical block propellant ammunition hold that made it superior to every rifle currently fielded by NATO forces? This is the history of the G11, the gun that solved the problem of the casing, only to be killed by the cost of its own genius. To understand the G11, one must first recognize the inherent flaw in every modern firearm: the brass casing. Since the mid-19th century, the metallic cartridge has been the standard. It seals the chamber, contains the propellant, and extracts the spent gas. But the casing creates three massive problems: weight and bulk. The metal casing accounts for almost 50% of the weight of the ammunition. This severely limits how much a soldier can carry. Logistics. The spent casing must be ejected, collected, or left behind, creating operational and environmental mess. Complexity. The spent casing must be forcefully pulled from the chamber, a critical step that requires complex extraction mechanisms and is the single largest source of rifle malfunctions. In the 1960s, NATO launched the ACR, Advanced Combat Rifle Program, demanding a weapon capable of increasing hit probability by a massive factor. West Germany, facing the Soviet threat, took the most radical approach, eliminating the casing entirely. Heckler & Koch's solution was the caseless round. Working with the chemical giant Dynamit Nobel, they developed ammunition where the propellant itself was molded into a solid nitrogen-based block that contained the projectile. This was revolutionary. The casing was replaced by a compact block of chemical propellant. The new round, the 4.73 by 33 mm, was lighter, smaller, and had no spent casing to eject. The potential savings in soldier weight and logistical simplicity were enormous. The G11 soldier could carry close to 1,000 rounds for the same weight that a standard M16 soldier carried only 300 rounds of brass-cased 5.56 mm. This logistical advantage alone was seen as a decisive factor against the massive manpower of the Soviet Union. To prove the concept viable, H&K and Dynamit Nobel developed the ammunition to be almost cubic in shape. A propellant block held together by nitrocellulose binder, with the projectile fully embedded inside. This block was chemically stable, designed to withstand the rigors of combat transport without degradation. The radical shape and material required a completely new firing system that could not rely on the conventional brass extraction process, setting the stage for the G11's unique mechanical design. Solving the ammunition problem, however, created a much larger mechanical problem. How do you safely load, fire, and seal a caseless block that produces massive heat and gas? The G11's answer was a masterpiece of mechanical complexity: the rotating breech chamber, housed within a mechanism designed as a kinetic energy absorption system, KEAS. Instead of a traditional bolt moving forward and backward, the G11 uses a rotary mechanism. Load. The chamber rotates 90 degrees to a vertical position. A fresh caseless block drops straight down from the magazine, directly into the chamber. The chamber is open only for the duration of the loading process. Seal. The chamber rotates back 90 degrees to the horizontal firing position, completely sealing the block within the housing. This sealed block configuration was crucial for controlling the gas and preventing the combustion from leaking backward into the rifle mechanism. Fire. The primer is ignited by a unique, minute, high-temperature hot gas jet, not a conventional firing pin. This system, called the ignition needle, was engineered to instantly ignite the block propellant without the thermal mass of a traditional firing pin, reducing the risk of cook-off. No ejection. Since there is no casing, there is no need for a massive extractor claw or ejection port. eliminating the majority of rifle failure points associated with extraction and debris. The entire operating system, from the magazine to the muzzle, was housed within the rifle's futuristic, non-traditional casing, or furniture. This allowed the firing mechanism to float independently within the casing. This sealed rotary system was not only reliable but allowed H&K to achieve the near-impossible goal of designing a weapon that was completely impervious to dirt, dust, and debris. A massive leap in battlefield reliability compared to every other gas-operated rifle in existence. Furthermore, the G11 was designed to be fitted with a complex, high-magnification optical sight as standard equipment, reflecting the West German military's commitment to precision and technological superiority over the Eastern Bloc. The G11's mechanical genius allowed for truly unique and devastating firing modes, specifically designed to meet the ACR program's goal of increased hit probability. The key feature was the hyper burst mode. In the traditional automatic mode, a rifle's recoil starts before the bullet has left the barrel, pushing the muzzle up and making subsequent shots miss. The G11 solved this through a complex system of mechanical delay using the Kinetic Energy Absorption System (KEAS). In hyperburst, the rifle fires 3 rounds at an incredible rate of 2,000 rounds per minute (RPM). The entire internal mechanism, the barrel, bolt, and magazine assembly, recoils backward as a single unit, compressing a spring. Crucially, the firing sequence is completed, and the 3 projectiles have left the barrel before the recoiling mass completes its rearward travel and hits the buffer stop. Only when the recoiling mass returns to its forward position does the shooter feel the recoil impulse. This meant the soldier could fire 3 shots, one after the other with machine gun speed, all landing on the same precise spot on the target, dramatically increasing the hit probability demanded by NATO. The performance results were staggering. In trials, the G11 easily outperformed competitors like the conventional FN Minimi. Furthermore, the caseless ammunition allowed a soldier to carry approximately 50% more rounds than the equivalent load of brass-cased ammunition. The G11 was proven, reliable, and fundamentally superior on paper. West Germany prepared to place a massive order, and the future of infantry combat seemed secure. Despite solving every technical problem presented to it, the G11 was ultimately sidelined by 3 massive non-technical issues: complexity, cost, and geopolitical collapse. The ammunition challenge, the cook-off problem. While the G11 managed the initial ignition, the caseless ammunition presented a major thermal hurdle. The propellant block proved highly sensitive to heat buildup inside the chamber during sustained automatic fire. If the chamber temperature exceeded a specific threshold, lower than brass, the block could spontaneously ignite, a dangerous condition known as cook-off. H&K's sealed rotary system was designed specifically to cool the chamber rapidly, but the physics of insulating the solid propellant from the heat of combustion proved incredibly difficult and costly to perfect under continuous fire, despite years of refinement. The cost of genius. The G11 was a mechanical marvel, but its unique rotating breech and hyperburst mechanism required an unprecedented number of custom, precision-machined parts, made primarily from costly polymers and lightweight alloys. It was vastly more expensive to manufacture and maintain than a standard Kalashnikov or M16. Estimates place the production cost of the G11 rifle alone at several times that of any competitor. This cost was already difficult to justify, especially as no other NATO nation was willing to abandon its established brass infrastructure to adopt the radical 4.73mm caliber. This isolation meant the cost burden fell almost entirely on West Germany. Then, in November 1989, the Berlin Wall fell. The geopolitical landscape of Europe dissolved overnight. The Soviet Union, the massive existential threat, the entire reason for the G11's existence, its expense, and its hyper-performance specification, vanished. The political priorities for a newly reunified Germany shifted massively. The nation had to absorb and rebuild the crumbling East German economy, dismantle the massive East German military apparatus, and integrate millions of citizens. Military spending was immediately slashed. The colossal budget required to finalize the G11 and deploy it could not be justified in a time of peace and economic integration. The G11 program, designed for a war that was no longer possible, was summarily killed. The technology was shelved, the tools were mothballed, and the revolutionary G11 never entered mass service. The legacy of the G11 is a bitter lesson that even technological perfection is irrelevant without political necessity and economic viability. The rifle remains a monument to engineering ambition, a gun that solved one of the oldest problems in warfare. only to be defeated by the complexity of its own solution and the sudden, devastating arrival of peace.